Hello everyone. In this video, I am going to explain about the data types and operators in C. So data types. So what is a data type is it specifies a type of data that a variable can store, such as it can be an integer, floating point number, or it is a character. The data types are classified into different types. They are basic, derived, derived, enumeration, and void. So the basic data types are furthermore classified as integer types and floating point types. The enumerated data types, they are again arithmetic types and are used to define variables that can only assign certain discrete integers throughout the program. Void returns no value, and derived data types are pointers, arrays, structures, union, and function types. Integer types. So what are the different types of integer types? So the first one is character. So character occupies the storage memory of 1 byte and its value ranges from minus 128 to 127 or 0 to 255 in decimal, hexadecimal. And then unsigned character occupies 1 byte and its value ranges from 0 to 255. Signed character, the storage size is 1 byte and its value ranges from minus 128 to plus 127. Integer occupies 2 to 4 bytes of space in the memory, and this is a value minus 327682 to 32767, or minus 2147483648 to 2147483647. Unsigned integers occupies 2 or 4 bytes and its value ranges from 0 to 65535. Short occupies a storage size of 2 bytes, and unsigned short uses a storage size of 2 bytes. Long occupies a storage size of 8 bytes, and unsigned long uses a storage size of 8 bytes. So integer data types, if you want to find what is the size of every data types, we can make use of the keyword called as size of. So for floating point types, the floating point type, the float, it uses a keyword called as float, and whose storage size is 4 byte, and double whose storage size is 8 byte, long double whose storage size is 10 byte, and these are the values and precision values of float, double, and long double. The void data type. The void data type does not have any return type, so we can make use of the functions as void. So if the function has a return type as void, means there is no return values. We can make use of void function arguments as void, and also pointers also as void, which we can see in the future sections. Next is the L and R values in expression. So L and R values are left and right side of the assignment operator. L value refers to an expression that represents a memory location, and the N value means expression which can be placed on the left hand side of the assignment operator, and R is assigned on the right hand side of the assignment operator. So this is a small code snippet which shows you the L and R values. So here int x is equal to 10. Here x is an L value, and the second step is int y equal to x, where x is an R value that is given on the right side of the assignment operator. Similarly, we can use the pointers using L and R values. So what are the different operator types? The different operator types are unary operator, binary operator, ternary operator. So unary operators are increment decrement operators. The operators used here are plus plus and minus minus. And Binary operators are classified as arithmetic operator, logical operator, relational operator, bitwise operator, and assignment operator. So arithmetic operators are plus, minus, asterisk, division, and modulo operators. Logical operators are and or operator, and relational operator are greater than, less than, greater than, equal to, less than, or equal to. Bitwise operators are and or left shift and right shift operators. Assignment operators are equal to, plus, equal to, minus, equal to. And the last is the ternary operator, and this is one of the conditional operator. And here we use a simple question mark and colon for ternary operators. So the arithmetic operators, the basic arithmetic operators are addition, subtraction, multiplication, and division. So these are the basic arithmetic operators. So let us see a code snippet of how the So how this operator works. So here in this case, we have used the value of a equal to 10, b equal to 20, and the another variable is assigned as c. So where we have used the value of c equal to a plus b. So what are the answers which we can find is c equal to a plus b. The first operation is c printf. Printf will print the values on the screen. So do this operation, when we do this operation, the first step is, so after this operation, c equal to a plus b. So the c value is printed as 30. Second, we have assigned c equal to a minus b. So the output of this expression, c is a minus b. So a minus b is, which is equal to minus 10. And the third one is a into b. So a into b is c equal to 10 into 20. So the values of c is 200. The last one is a divided by b. So a divided by b is 10 divided by 20. So the value of 10 divided by b will be printed. And in this case, c equal to a modulo b. So a modulo b means 10 divided by 20, and the result will be the remainder of this a divided by b. So a divided by what we have done. So that will be printed as a result. So these are the results which we can see here. So a plus b is 30, a minus b is minus 10, a into b is 200, a divided by b is 0, and the remainder for a modulo b is, the remainder is 10. So the relational operator. So relational operator checks the relationship between two operands, and the relational operator are specifically used to compare some two quantities. If the relation is true, it returns 1. If the relation is false, it returns 0. So the relational operators. So the relational operators used here are equal to, greater than, less than, not equal to, greater than or equal to, less than or equal to. So the relational operators, this is a simple code snippet which shows you the how the relational operator works. So we have used x is equal to 5 in this case and y equal to 3. But if here in this expression we have used a relational operator x equal to y, so this will return the value as false because x is not equal 5 is not equal to 3. So this value will print this expression. So this is output. So the output is 0. Relational operator. So if in this code snippet you can see the value of x is equal to 5, y equal to 5. So both values are equal to 5. So the output will return 1. So the output is 1. Similarly, for not equal to. So in this case, the value of x is equal to 5 and y equal to 3. and these two values are not equal, so the output will be, it will return the value as 1. In this case, the value of x is equal to 5 and y equal to 3. So here the x value is 5 and y value is 3. So it returns the value as 1. Since it is greater than 3, the output is 1. So the next comes a logical operator. So the logical operator returns either 0 or 1 depending on whether the expression is true or false. So normally we use this logical operator for decision making. So there are three types of logical operator. So logical AND, which is going to check any two expressions. So we use two ampersand symbols for logical AND, two slash symbols for logical OR, and this is for logical NOT. So for example, in this code snippet, the value of a equal to 5 and b equal to 5 and c equal to 10. So this result equal to it, we are using this relational operator and followed by means of a logical operator. So a equal to b. So a equal to b means this value is true. And c greater than b. So c is greater than b. True. So the output of this expression should be equal to, so 1 and 1. So 1 and 1. So the output is equal to 1. Similarly, the second expression, if you see a equal to b and c less than b. So this value is a equal to b is 1, that is true, and c is less than b is false, so it is 0. So 1 and 0 is 0. The next expression is result a equal to b or c less than b. A equal to b is 1 and c less than b is 0. So if any one of the input is 1, the output will be equal to 1. So this expression will give the result as 1. So the next is a not equal to b. So a is not equal to b, both, but this condition is 0. C is less than b is also equal to 0. So 0 or 0. Both the inputs are 0 for an OR gate means the output is equal to 0. So the next is result is not of a not equal to b. So not of a is not equal to b, 0. So the output is equal to 1. So the inversion of 0 is 1. And result equal to not of a equal to b. So the a equal to b is 1. Not of 0 is, not of 1 is 0. So if you see this expression, you can find the following output. This is the output of this program. So for the first one, the output is 1. Second case, output is 0. Third case, 1, 0, 1, and 0. Ternary operator. So conditional operator is similar to if-else statement in that it follows the same algorithm, but the conditional operator takes less space and helps to write if-else statement in a shortest possible way. So for which we are using ternary operator. So how do you write a ternary operator is, the first case is we are using the variable. So variable equal to expression 1 and expression 2. If this is true, so the value will be stored in the variable. If this is not, the second value will be stored in the variable. If not, so likewise. So we are using multiple if loops. So if you are using an if else statement, so for this we can use a ternary operator. So the syntax will be like this. If expression 1, the first set of variable will be code will be executed. If this is not true, it will go to the else and this expression will be executed. So in this we are using a conditional operator called question mark. So for example, if you take this, if m equal to 10, n equal to 8, if m greater than n, so this condition itself is true. So if this is true means m is greater than n will be executed and it will not go to the next state. So you can see 10 m is greater than n, the first set of printf statement, this printf statement will be executed. So then we go for increment and decrement operator. So increment and decrement operator is denoted by plus plus and minus minus. Plus plus and minus minus. This is so increment, which means that increment the value by 1 or decrement the value by 1. In this case, first statement, this is a small snippet showing the increment and decrement operator. In this, the value of A is assigned as 10, the value of B assigned as 6, and C as 12, and D as 15. So plus plus A, the value of A will be incremented, so it becomes 11. Minus minus B means the value will be decremented and the value becomes 5. Plus plus C means the value of C is 12, the incremented value is 13. Minus minus D means the value is 15, so the value is decremented by 1. So this is the output of the program 11, 5, 13 and 14. So similarly, previously pre-increment and post-increment. Previous code snippet shows a pre-increment operator and this shows a post-increment operator. So if you see the values, post-increment, so the value is same. A equal to 10, B equal to 6, C equal to 12 and D equal to 15. Bitwise operators, similarly, we have few bitwise operators like the operators, these kind of operators will operate on bitwise operations. So the bitwise operators are and one single ampersand for and, which will do bitwise operation. This is for logical or slash, and caret symbol is for XOR, and tilde is for complement. So bitwise and so this is a truth table for bitwise and, which you might have learnt in digital system. If both the inputs are 0 or any one of the input is 0, the output goes to the 0 state itself. And other case, if both inputs are 1, only the output is equal to 1. This is for bitwise and. So you can see the integer value A equal to 2, B equal to 3 and C equal to A into B. So A into B means, okay, you can see the, as per the table you can do. If any one of the input is 0, the output is 0. Both the inputs are 1, the output is equal to 1. Both are 0, 0. So the output of this expression is 2. So bitwise R is, if any one of the input is 1, the output is equal to 1. Both the inputs are 0 means the output is equal to 0. So for which this is a small code snippet A or B. If you take A or B, if any one of the input is 1, the output is 1, elsewhere it is 0. So the output is equal to 3. So XOR is a different truth table. So in this case, if any one of, so for say like signs, the output is equal to 0. For unlike signs, the output is equal to 1. So if any unlike inputs are there, the output is 1. And if it is the same inputs are there, means the output is equal to 0. This is a simple truth table for you to remember the XOR gate. Similarly, the inputs are given here, X C equal to A XOR B. So for unlike signs, the output is equal to 1. Elsewhere, it is 0. So the output is equal to 1. The output is 1. So for negation operator, it will complement. If the 0 is the input, 1 is output, 1 is the input, 0 is output. So this is a simple case showing this. So if the input is 0, 0, 0, 0, 0, 1, 0, the output is 1, 0, 1, 1, 0, 1. So the output is minus 3. Bitwise negation. So bitwise negation is given by bitwise negation of 2 is minus 3. So how we have to do this procedure is, first is apply the negation. So apply negation means we have to take the 2's complement of the input. So the input is my so the input is 2. So the input is 2 means 0, 0, 1, 0. We have to take 1's complement of this result. 1's complement means convert zeros to 1 and 1 to 0. So when you convert this, so the value becomes 1, 1, 0, 0, 1. And 1, 1, 0, 1, you have to add uh, you have to take 2's complement of the result again. So 2's complement of the result is 0, 0, 1, 0 and plus 1. So plus 1 is 0, 0, 1, 1. So this is the equivalent decimal value, that is minus 3. So coming to the next bitwise operator is left shift and or right shift operator. So for your left shift operator, it is given by lesser than symbol, and right shift operator is given by greater than symbol. So these are some few operators used in motor drive control applications in embedded C programming to shift the motor right and left. So in this case, we are using the left shift and right shift operator. So for example, this is a small scenario showing what is a left shift operator. So left shift operator means the value of A is equal to 10, and we have to left shift the value of 10 twice. So in the memory, the the value of 10 is given by, so it occupies 8-bit position. So all the most significant bits are taken as 0. The value of 10 is 1010. That is a decimal equivalent. So how we perform this operation is, see, this is a binary format. We have to perform the left shift operation. These two bits will be discarded. So these two bits will be discarded, and all the bits will be shifted left twice. So you can see the value 0, 0, 1, 0, 1, 0. So these values will be used, and the last two values will be filled by means of 0. So this is the left shift operation. So the output for this case is, so if you take the bit value of this value, so it is almost 32 plus 8. So that is equal to 40. So 10 left shifted twice will give you 40. This shows a right shift operation. So right shift operation means we have to shift right. So these two bits will be removed. So what are the two bits that will be removed is 1, 0. So all the other bits will occupy the remaining position, and the filled most significant two bits will be filled by means of 0. So if you see the output of this, the output is 2. So this is a simple program, shows bitwise operation. So 10 left shifted twice is will give you 40. So for example, this in this case 10 right shifted by 2. So 10 right shifted by 2 will, the output is 2. So for example, 0, 0, 0, 0, 1, 0. This when you shift these two bits, so right shifted by 2 again will, the output becomes 2, and the most significant bits will be replaced by means of 0. So this value is 2. So with signed integers, we have signed magnitude, 1's complement and 2's complement. So in this one example I'm giving you, so in this case minus 13, how it is left shifted by 2. This is a small code snippet, and the value of the output of this program is minus 52. The working is simple. So internally how it happens is, so the value of 13, so it is represented by means of 8 bits. The most significant 4 bits are taken as 0, 0, 0, 0, and the value of 13 is 1, 1, 0, 1. So first we have to convert, find 2's complement of this input. When you take 2's complement, convert all zeros to 1 and 1 to 0. So in this case, when you convert this, the output becomes 1 1 1 1 0 0 1 0, and then add 1 to it. So from this, triple double one double one 0 0 1 1. So this is a 2's complement of 13. When we perform shifting, so when we perform this shifting, the output becomes 1 1 0 0 1 1 0 0. So when this is after shifting, left shift by 2. After that, we have to take this, when you take the 2's complement of this result, we get 1 1, 0 0 1 1 0 0 1 1 plus 1. So the output is 0 0 1 1 0 1 0 0. This is the equivalent value and whose decimal value is 52. So when you see the result, so in this case, the decimal value is 52. So comma operator is used to link the related expression. So in this way, you can use a comma operator int a comma c, which is equal to 5 comma d. Size of operator is used to tell what is the size of the variable you have taken. It may be integer or float or character or whatever it is. So in this, you can see the statement size of. So size of a. So size of a, the integer value, that is the integer size will be given here. So the next is integer occupies 4 bytes, float occupies 4 bytes, and a double is also 8, and character is 1 byte. So the expressions are, so when you take the expression, so this is a variable operator, and x and y are the operand. So a plus is operator, a is a variable, x and y are the operand. This is how you declare an expression. So infix expression a equal to x plus y. So the different types of expression declaration is infix a equal to x plus y. Postfix is xy plus. Prefix is plus xy. Unary is x plus plus. And binary expression is x plus y. So types of expression we can classify into arithmetic, conditional, pointer, bitwise, logical, and relational. So arithmetic is plus, minus, asterisk, and slash, and um, relational is greater than or equal to, less than or equal to, plus equal to, minus equal to. Logical is ampersand, or, and not operators. So types of expression is conditional expression, pointer expression, and bitwise expressions. So this is a simple program showing the expressions. So arithmetic expression, if you see the arithmetic expression, 6 into 2 plus 7 minus 9. So the expression within the parenthesis will be executed at first. And this is a relational expression in which 7 greater than 9 and 5 less than or equal to 9. So the relational expression is b percentage 2 not equal to 0. This is a relation. This is an example for logical expression. Conditional is we are using ternary operators. And the last is pointer expression where we use address of the variable. Bitwise operation is using the right shift, and this is for bitwise operation is to perform bitwise operation, and right shift and left shift operator is used to shift the bits right or left. So the output for the previous program is given here. So operator precedence is which operator has to be given the highest priority. In this, the precedence is given to first asterisk is higher than minus and then equal to. So 17 into 9 is evaluated and then followed by minus. So these are the operator precedence: postfix, unary, operator, multiplicative operator is given the next priority, then additive shift, then followed by relational equality, bitwise and bitwise or, bitwise XOR, bitwise or, logical and, logical or, conditional, assignment and comma. Thank you. So you might have a good idea on operators and data types.